I'm Jeremy Malczyk, developer on the Map of Life project out of Yale University under PIs Walter Yetz and Rob Goralnik, who's in Florida now. Map of Life is a biodiversity project that's aiming to build a scalable platform for large biodiversity and environmental data. We built it on App Engine, Earth Engine, and CartoDB. Everything's in the cloud. And we're aiming to produce the best possible species range maps that can be made from all the available data that's out there right now. So it's very ambitious, borderline impossible. So here's your typical range map. It's super coarse. It's just a blob. It really is supposed to describe where a species may live, but that does not mean that it lives everywhere in there. You know, it really should think of it as everything. It doesn't exist outside of that, or is known to not exist outside of that. But we know that this species is a forest specialist. It's a mouse, so I had a picture in it, but Dave grabbed this too early. So we've come up with a tool that improves that. So we've got all these other data sources that we've harvested outside of the range maps. But for this one, you can see there's not a whole lot. All we have is a smattering of points that generally fall within the range. So it seems like it's a decent map, but we can obviously improve it more. And it's just a few points. It's really not covering. It's not really showing much detail there. So here's the tool. And what this does is it applies a deductive model that just basically takes the land cover preferences and that this species would be suitable for this species, removes the pixels that shouldn't belong, and then we test it with the occurrence data that we have. And this is occurrences after, I think, 1990. So the blue ones are ones that fall within the suitable habitat, and the red ones are the ones that fall outside of it. From that, we can generate, we can calculate the area that is suitable and come up with and the number of points that fall in and out, and come up with a map improvement score, which Walter could explain to you at 65% improved. I'm not 100% confident on what that really means, to be honest with you. So once we have this improved range map, we can intersect it with the parks data that we have. So this is from the WDPA. The blue areas, if you can make them out, are parks that are strict, and the rest, the tan ones, are not so strict. So you can see that there's this target. So for a given range size, there's a target area that is deemed for protection that we're trying to hit, which is sort of a ratio of that total, depending on how big it is. So the target area for this guy is pretty big. It's bigger than its total area, and within this refined map, we're only hitting about 36.7% of it. And within that, only 28 of the 31 parks are bigger than 10 kilometers. There's some parks that are just so small that it wouldn't really make that much of a difference. And if you bump that up even higher to 100 square kilometers, you can see that the target, that there's even more that fall out of it. Okay, so one thing that we'd like the tool that we've been developing on top of this is to actually extrapolate this across all of the years that we have in for MODIS data for the land cover, and for this is the Hansen tree cover layer, so that we can establish trends. And show some charts for that. And the other thing that we've been doing has been running this. So this is available for a handful of species right now. We can do it for all species except for really big ones. We have some performance issues, but we're pre-computing all these metrics for everything and causing headaches for people on the Earth Engine team.